Hi, everybody. It's so nice to meet you. My name is Margaret Tanzash, and as I mentioned a little bit earlier, I've been using the CS50, CS50 AP, CS50X curriculum for about 7 years in a high school environment. And what I'm going to talk about today is how I've adapted the curriculum. And again, it doesn't have to be specifically for the AP curriculum. I use it also for my introductory classes. And there's so many opportunities to use it in different ways. I just want to share with you some of what I've been doing. So in terms of my own background, I teach at a school called New Explorations into Science, Technology, and Math, kind of a mouthful. And I generally have 4 sections of computer science intro class, 1 section of AP Computer Science Principles, and I have a lot of students. I'm in New York City, and our class sizes are large. I mean, they go up to about 34 per class. So I have generally about 150 students. I've also been teaching the last few years at the Harvard Extension School as a teaching fellow, Harvard Summer School, and I've got experience as an AP Computer Science Principles reader. So I know a little bit about that. If anybody's interested in some of that, we can talk about that later as well. This is a picture of my school. It's located on the Lower East Side of Manhattan. It's an unusual school. It's one of the few K-12 schools in New York City. It's a regular public school, gifted and talented, they call it, because there's a bit of screening for students. And so students come in basically prepared and ready to learn. But even despite that, I have a very wide range of students in my classes. Students that know absolutely nothing about programming. Sometimes their parents kind of encourage them to take the class. Some that might have done a little bit of web development, and some that are quite experienced. They created their own bots, already know they want to major in CS, might have been programming on their own for years. So mostly 11th and 12th graders. So the CS50 curriculum really works for that environment because, as David had said, it's really created to work for more and less comfortable students. I like to keep the class exciting with events. I like to keep it engaging. And pre-COVID, we were able to do it, hopefully very soon again, a lot of really fun activities. We had a number of hackathons at the school, and you can see this is back from 2019. David Malan came. The students were thrilled. We had a tremendous amount of fun. We've done Puzzle Day every year, and this is the library in our school where students are working on various different puzzles and at the end presenting their solutions. And this was, since we're in New York City, we would sometimes get a bus and we'd come up to the Yale version of the CS50 Fair. And these are a bunch of my students, again, back in 2019. It was the highlight of the year for many of my students. So what I wanted to do was just, now I know you did it last time, but maybe we'll meet some different people this time. If Carter could make some breakout rooms, just take a few moments again, meet somebody different, so that hopefully you come away from here with a few new connections, introduce yourself, where you teach, etc. Maybe a little bit about what you hope to get out of the workshop. So let's just take about 60 seconds and everybody can join a breakout room. That would be great. And then we'll come back and we'll continue with this. All right, pretty much everybody back? All right, fabulous. I see a few more people coming in. Hang on just another few seconds. Hopefully you all had a chance to meet somebody different. And one of the things I really love is just been such a really wonderful community, the CS50 community. So, hopefully you'll all, if you haven't been in touch with us, if you're a new teacher at CS50, have the opportunity to continue to maintain that relationship. So what I wanted to start out was talking a little bit about what I do. Some of the reasons I'm so excited about CS50, some of the reasons I see it even getting better as we go forward, and some of the things that I'm thinking to do to enhance my own curriculum. So I consider myself an adapter. I use CS50 in different ways for different classes. For my introductory class, and again, my intro class is sometimes full of people who are students who are just maybe getting their feet wet for the first time, not sure if they're going to like computer science, sometimes a little bit afraid that it might not be something they could handle. So I try to make it very friendly, very introductory, but also giving students who have more experience the opportunity to move much more quickly. So for my introductory class, I usually use weeks 0, 1, and 2. And in the AP curriculum, you'll notice there are also past problems. So there are more than just the problems that are done at Harvard, which ramp up a little bit more quickly. There's problems in addition to starting with hello and going right to Mario in week 1, for instance. There's older problems that I sometimes use, like Fahrenheit and pennies and ISBN. that kind of allow students to kind of, to scaffold their skills up so that when they get to Mario, they're already a little bit familiar with some of the various programming constructs. So in my introductory class, I use pretty much weeks 0, 1, and 2 as required programs. And then for more advanced students, what's great is that they can just almost act as adopters and just kind of move ahead with CS50 on their own. They have so many resources. They have the lecture videos, they have notes, they have shorts, they have the check 50s to tell them if they're doing their problems correctly. So they just sometimes go ahead, and there's really never a reason for anybody to be bored. Semester 2 for my introductory class, I start out with a little bit of a shift to doing some web design. So we do what's called the homepage project in the CS50 curriculum, which is creating a web page using CSS and JavaScript, and there's various criteria that go with that. And they love that. A lot of students now, it's like they're in a familiar environment, they use color, they're using images, and I actually have them create a website. I come up with a topic for them about a place in New York that's really near and dear to their hearts, their version of New York. So it's a very personal website. And then I have them put it up on what are called GitHub pages. So they could create a permanent URL now and share it with their family and friends. And then we kind of move a little bit away from CS50, and I do some JavaScript with them. And there's something called P5.js, some of you may have heard of, and I work with them and create some specifications to help them make some games. Particularly spring, by the time it comes to spring of the year, we actually our classes in New York go until the very end of June. So, it's a lot of them begin to enjoy making games and sharing the games with each other. So I try to keep it very engaging. For my AP class, some of them are already taken. A lot of them have taken the intro class. And so we'll move ahead with weeks 3 and 4, specifically because 3 has the searching and sorting algorithms within it, which are really important for the AP multiple choice exam to understand that. 4 has images, so they experience a little bit of images and a little bit of files. And then I kind of jump ahead. I don't usually do, just for advanced students, they may do memory management on their own, but I generally don't do that with my entire class. We move ahead to Python. And it depends on the year. It's been an unusual couple of years with remote classes and now back in person. So we sometimes get to SQL and Flask, and sometimes we don't. It depends on the year. What I'm thinking of doing this year, because we have this fabulous new Python course, is maybe instead of going down the road after going through a little bit of C, some of the weeks 3 and 4 material, of switching over to the Python course so that students could now really become a little more familiar with Python. And in the AP curriculum, they have to do what's called the Create task, which I'll talk about in a bit, which means creating a program basically on their own. And so I'm thinking that I may consider doing that so that they have a little bit more skill in terms of creating a program if they choose to do that program in Python. My classes are 5 days a week, and I have 45-minute periods. So that's kind of what my year looks like. And some of the reasons I'm so excited about this curriculum is that you really can make it your own. It doesn't have to be, a lot of people think that, oh my gosh, it's from Harvard, or oh my gosh, it's such a hard class. But again, it depends on how you make it. So you don't have to use the entire curriculum. You could just take the first couple of weeks, which are an amazing introduction to computer science, and then move more slowly, as David was saying. You don't have to do it in that short time segment that you have to do at the college level, right? So I'm a little bit more flexible. I give students a lot of time to complete their problems. And then I introduce, as I said, some of the past problems so that there are more Unit 1 or Chapter 1 problems. There are more Unit 2 problems than just the 3 or 4 that they do at the college level, so that they could get more experience. And then again, I do allow a lot of differentiation, which is a really, of course, my administrators love that. It's a really great thing to be able to do. And with this curriculum, it makes it really possible to do that. And again, I allow students to see it more as an introduction or a little more advanced for some students that want to get into more significant material. Now, one of the things that I've been doing this summer that I'm even more excited about is creating a whole suite of practice problems. So these are small bite-sized problems that are going to be embedded in every week or unit. And so there are already a few that are in there. They're still going to be tweaked, and there'll be some changes made. And hopefully they'll be finished, I believe pretty much about the middle of August. But the idea is that each problem deals with maybe 1 or 2 concepts. So it's not as sophisticated as having to try to figure out how to use nested loops in Mario. but maybe just using a loop. So these problems, and I'm going to show you in a moment what they look like, they are also, in an attempt to have something connected to a real world situation, like maybe how to split the bill when you go to dinner with somebody, or, how to calculate a total if you're selecting items from a snack bar, something like that. And so I see my ability to be able to use those problems with my own students to have more shorter, simpler problems to kind of scaffold up to get them ready for the PSET problems. And I think that that's going to be a great addition. And also, of course, with the Python course as well, you can implement that. As I said, you can go from C to Python and maybe put off getting to some of the Flask and SQL applications. And so with the practice problems, there'll be at least 3 short problems per unit. And each one demonstrates a key concept. So they're going to be concepts that you need to understand to really come out of that unit proficiently, but again, in an easier start to each one. Each of them will have check 50s and submit 50s. If you're familiar with the curriculum, meaning that your students can submit it and be automatically graded for correctness and style. So you can use them as assignments. They don't have to be just a practice problem or a demonstration problem. Again, it's up to you. I'll be using them probably as a combination, maybe using one as a kind of a demonstration problem, doing it as a code along with the class, and other problems that they'll do as assignments. And I also may scaffold so that for some students that maybe come in really, really super less comfy, maybe even use those instead of some of the bigger PSET problems. I'm still figuring out how I'm going to do it, but I feel like it just leaves a lot of opportunities to differentiate. And then each of them comes with a thought question, which I'm excited about because it's something to kind of prompt you, maybe to open up the unit or to, when the student finishes the problem, to be able to encourage more classroom discussion. So this is where they'll be located. If you're familiar with the pages with the AP curriculum, you'll see on the bottom there's going to be a section for practice problems. And the other thing is that these practice problems, as I'm going to show you in a moment, if you're using the AP Computer Science Principles curriculum, you'll note that the Create task, which is a program that the student has to create either individually or collaboratively, it has to have some very, very specific criteria. And so I found that actually it's really useful to do practice problems with students because students get graded primarily on writing a program that has the correct criteria, but then most importantly, being able to respond to prompts where they write about the purpose of their program and write about their algorithms and how they simplify the coding. So sometimes it's hard to come up with ideas, I found, of a program that satisfies the criteria. So I have a couple of different programs I'm creating with the practice programs that satisfy the criteria of the Create task, which are things like the program has to have input, it has to have an array or a list that manages complexity, not just an array for an array's sake, but something that's meaningful. It has to have a function or procedure, as they call it, that uses one or more parameters. The function should contain an algorithm that uses sequencing, selection, and iteration, meaning an if statement and a loop. And that has to have an argument that's passed into the function that impacts on a chunk of code that's going to execute. So there could theoretically be a different argument that causes a different segment of code to execute. And sometimes I find it's not always that easy to come up with that type of scenario. So that's why a couple of these practice problems do fit this particular criteria. And while they can't be used for a student to submit this to the College Board as their Create task, it could be used as a way of having something the student could write about for practice. So these 3 problems are a few of the problems that I'm starting with that will meet that criteria. And in order to, again, if you're using the AP Computer Science Principles curriculum, realistically, you only have to go up to week 2 to have all the knowledge necessary to create a program that satisfies Create. So again, if you're working with students that need more time, that may not be really ready to get in some of the sophisticated stuff, you could literally go up to week 2 and they have the knowledge they need to do the Create task. So one of the programs, for instance, is called Hours. And this is going to be, again, some of these are already on the AP website, and again, they'll probably be tweaked. But the idea of this problem, it's really pretty simple. And it just asks a student, for instance, perhaps they're taking CS50 and they want to calculate how many hours they're spending on their homework. And maybe they want to either have a total number of hours or an average. And so there's a little bit of distribution code. I have like a little demo in each one that shows the student what the inputs and the outputs are going to look like, so they know what they're shooting for, right? They know how their program should behave. Some implementation details, the thought question, for instance, maybe asking in this scenario, what is the advantage of using a function to calculate hours? Many of them have also used functions because I think it's really helpful for students to get practice creating functions. How to test their code, a check 50 and a submit 50. And so again, this to give you an idea of what the program might look like. This is an example of the solution for that program. So in C, this is your prototype. This is the main function where you're really just prompting for hours, saving information in an array. And then the function itself is over here where you have, and again, sometimes it might be trying to, with this create task, trying to find a solution that fits the problem description. But the idea is that you may not always want to have a function that has either a total or an average, but in this case, I put them both in one function so that you have that if-else statement. In other words, if the total is being requested hours a week, you execute one chunk of code, and if the average is what's being requested, you execute a second chunk of code. So again, you have your loop, you have your condition, you have input arguments that impact how the function actually executes. Super, super simple. Probably one of the simplest type of programs you could create that satisfy the create test. But again, just giving students a real example and an idea of what's possible, like what they could do. I have another program called Snack Bar, which is in Unit 3, which uses C structs. And you can see here, the idea is that students have a menu to choose from, and they are going to say certain food items they want to purchase, and it will give them the cost of it. Again, not very hard, not very difficult, but again, demonstrates certain concepts. I have on the top of each of these also what are the learning goals here. So here they get some practice using structs, and they also get practice writing a linear search algorithm, not just searching for numbers, but here actually searching through a struct. So they're going to be searching for certain food items, and then you're going to be, from the function, returning the price. So again, a little bit of distribution code, a thought question, why is an array of structs maybe a better solution than multiple arrays? Again, just to have something kind of at your fingertips to be able to use. Because sometimes when I'm teaching, it's sometimes not always easy to come up with a little question to propose to the class. So just some ideas. So again, this is another one of the practice programs that could possibly be used. And then this is the what it looks like for the Python course, which you can see there's 9 weeks. It's just all programming in Python. It goes deeper than the Python that you get in the traditional CS50, which is basically week 6. And I think it's really exciting. So I know a lot of my students are interested in learning Python. People here, it's the up-and-coming language. And so what my plan is to use the first few weeks of these after they get past the first few weeks of C. And then we'll transition into Python. And probably I'm going to try it this year, maybe not do the Flask and Jinja and SQL, except for students that really want to go there. So I will give students that option. But maybe for the average student, we'll focus on Python so they have more time to really get proficient coding in Python, which I think a lot of them want to do. So again, I'm just throwing out my thoughts. This is all new. But I feel like it really gives you a lot of different directions that you can go with all of this and a lot of ways that you can customize it. CS50 Labs I've talked a lot about when I've done this in the past. And so the CS50 Lab environment will be migrating to use the new VS Code on the right. And Ranshin will be talking about that a little bit later. But I often like to use the first few programs in CS50 in the lab environment because, again, you have scaffolding on the left and you have buttons that provide hints and things along those lines. Buttons that allow you to just present a little bit of information at a time so that you don't have to see a long screen full of information for some of the problem sets. So we'll see. I mean, this will be available, and it's an environment that's available for teachers to make up your own labs as well. You could use this to create your own custom problems that you might want to make in this particular lab environment, kind of almost create your own course that runs along with CS50. So again, a lot of tools, a lot of options. There's a CS50 handbook that Carter will be talking about later. And if we take a quick look at this, there's a whole section for CS50 AP and just links to everything you might need, links to the homepage for the CS50 AP curriculum, links to where you find solutions to problems if you're a teacher, ideas for daily checks and different grading and feedback ideas. So the practice problems, again, will be here, lesson materials, and then documentation. So just a nice place to find everything. And again, try to make it something that people can kind of make your own, and yet have a lot of guidance and have a community to work with you. So what I wanted to do, some ideas that I had that I would love to maybe crowdsource with folks from here that might be interested in communicating about this, might be if you're using the AP curriculum, maybe doing things like introducing some of the language from the AP curriculum earlier on in the course. So the College Board uses language like procedures instead of functions, iteration instead of loops, selection instead of if statements. And I found that sometimes students get a bit confused in terms of knowing what they're saying, because in CS50 we talk about functions and loops and conditionals or if statements. So if anybody's interested, I thought it might be a nice thing to maybe create materials that go along with each unit that might have a little bit of like vocabulary translation, or maybe some of the AP classroom practice problems, which are done in an agnostic language using kind of a pseudocode environment, to be able to kind of give them little like practice questions in the College Board format that relates to the material that they've just learned, perhaps that relates to loops and conditional statements, but in the pseudocode-like language that the College Board uses for the multiple choice exam. So we're looking like we're going to have another Google group. If anybody is here from a while back, we used to have a Google group where teachers were able to really have a wonderful community, ask questions and answer questions and have threads on numerous different topics. And we're going to be having that again, which will be great. And I'm hopeful that we could create an environment there to have a real community where we could kind of share our ideas, find out what's helpful, what we need, and share our resources with each other as well. So I'm hopeful that we'll be able to stay in touch and communicate through that and have an ongoing support network, in addition to all the fabulous materials that we have through the CS50 team here.